Hi, I'm Lynn Turback, and this is the first of a sequence of screencasts on the second half of the Objects from Scratch lecture slides. These slides were originally handed out in Lecture 16th on Friday, April 5th, and we plan to cover the second half of these slides in lecture on Friday, April 19th. However, those plans were derailed when all Wellesley classes were canceled on that day due to the surreal events involving the manhunt for the Boston Marathon bombers that basically shut down the entire city of Boston that day. This screencast presents the material that Brian, Jaden, and I would have covered in lecture on that day. We're going to begin on slide 15 with the Buggles from Scratch example. Now, many of you have done at least part of this example in lecture already on Friday, April 5th, but I'm going to begin with this because it's a very important example and it's closely related to the text turtle problem that you have in Task 1 on Problem Set 9. So here's the setup. You have your computer, you're not connected to the internet, and you accidentally delete your Buggle class, but you need to do some Buggle programming. Oh no, what to do now? Well, it turns out all is not lost because you now know enough to create some simple Buggles from scratch. We're going to ignore things like graphics and walls and bagels, which add complications, and just focus on the basic Buggle. So we want you to be able to create instances of the Buggle class that look like this. They have 4 instance variables. We'll call them pos, which holds a location, dir, which holds a direction, call, which holds a color, and brush down, which holds a boolean indicating whether the Buggles brushes down or not. And what I'd like you to do right now is to pause this screencast and to write down on a piece of paper the declarations that you would need to make for the 4 instance variables of this Buggle class. Okay, your declarations are going to go inside this skeleton for the declaration for the Buggle class. And such a declaration has the keyword class, it has the name of the class, which is Buggle, and we declare it public, which means other people get to use this class. And what do the instance variable declarations look like? Well, to declare the pos instance variable, we're going to write this. Okay, what this says is that the name of the instance variable is pos, the type of the instance variable is location, that is, this variable will hold a location. And we're going to declare that this is a private instance variable, which means that code outside the Buggle class cannot access the pos variable. And as a default, you should make all of your instance variables private unless you have a darn good reason to make them public. And we'll study why that's so in a later lecture on data abstraction. Okay, so what are the other instance variable declarations going to look like? They're going to be very similar. So for dir, we're going to declare that it's a direction variable. For call, we're going to declare that it's a color variable. And for brush down, we're going to declare that it's a Boolean variable. Now, in this case, we happen to have put all 4 instance variables at the top of the Buggle class declaration, but in fact, they can go anywhere. We can put them at the top, at the bottom. We can put some at the top, some at the bottom, some in the middle. That would be a little bit perverse, and it's generally a good idea to put your instance variables at the top of your class declaration. And also, how do we know that these are instance variable declarations? Well, they're not local variable declarations because they're not inside some sort of method. And they don't have the keyword static associated with them, so they're not class variable declarations. So any variable declarations that you see that are inside the class declaration but are not inside some sort of method, and they do not have the keyword static associated with them, are instance variables. So these are the instance variables of the Buggle class. Okay, now we'd like to go on and talk about the constructor method. So the constructor method is something that's going to go off and create an instance of the class. Let's momentarily jump forward to slide 20, which reminds us that when the constructor for a class is called, it automatically creates an instance that has a slot for each of the declared instance variables. And each of those slots is filled with the default value of the type for that instance variable. For instance, ints are filled with the default value 0, doubles are filled with 0.0, booleans are filled with false, and other object types are filled with the special value null. So for the case of Buggles, we have 3 instance variables, pause, dur, and call, that are all object types and are filled with the value null, and brush down, which is a Boolean type and is filled with false. But those are not the values that we would like for a new Buggle. So we know that when we create a new Buggle, we want the initial position to be 1, 1, the initial direction to be east, the initial color to be red, and the initial brush down to be true. So the task that we have at hand in defining a Buggle constructor is to make sure that each of these variables is filled with the correct initial value rather than the default value. Now we'll discuss the definition of the constructor method for the Buggle class. This slide does not appear in your handout, but we'll use it to explain the details of the definition and how it works. First of all, for the definition, recall that a constructor method has the name of its class as its name, and it's followed by parentheses that surround the declaration of the parameters for that method. In this case, when we invoke a Buggle constructor, we don't expect it to have any parameters. We declare this constructor to be public because we want code anywhere to be able to invoke the constructor method for the Buggle class. Now below here we see in execution land what happens when we invoke this constructor method by calling new Buggle without any parameters. And even in its current state, without any body whatsoever, this constructor method would still do something. In particular, in object land, an instance object would be created with 4 slots that are determined by the declaration of the instance variables for the Buggle class, filled with their default values. And in the execution frame, we would have the special variable this holding on to a pointer to that Buggle object. So even without any body whatsoever, this constructor method would still do something, and at the end of the constructor method, it would return the value of b1. So now what I want you to do is I want you to pause this screencast and flesh out the body here so that it contains assignment statements that would change the values of the 4 slots to be the values that we want them to have at the end of the execution of the constructor method. Here's how we would flesh out the body of our Buggle constructor method to do the right thing with initializing the instance variables. To initialize the pause variable, we would write this assignment. This.pause gets new location 1, 1. And we can see in execution land that when we execute this assignment, the variable this will denote a reference to b1, new location will denote the object location 1, 1, and the assignment will store the 1, 1 into b1's pause variable. And similarly, we can change the direction by saying this.dir gets direction.east, and that will flesh out the dir variable of b1 to be east. This.call gets color red, we'll change the call variable of b1 to be red, and this.brushdown gets true, we'll change the brushdown variable of b1 to be true. And at the end, the value of this would be returned by the Buggle constructor, and now it would return a correct Buggle. A somewhat bizarre but important detail of Java is that the this dots within a constructor method or instance method, when they refer to an instance variable, are actually optional. So we could actually write the constructor method like this. Now normally we would expect that this would give an error, because what are we doing? We're referring to a variable pause, and the variable pause does not appear in the variable section of our execution frame. And normally we would expect that to be an error. However, Java has a special case. If a variable does not appear in the execution frame, it will look to see if that variable appears as the instance variable associated with this. So in this case, because pause is a variable that appears in the instance this, it will treat it as if we had written this.pause. And then it proceeds as if we had written this.pause, and everything works correctly. So again, we can refer to instance variables in constructor and instance methods without the this dot, And if there is no variable by that name in the execution frame, it will automatically go and assume that that is the instance variable associated with the variable this. To wrap up our discussion of constructor methods, I'd like to say two more things. The first, which is discussed on slide 21, has to do with the special value null, which is the default value for objects. And it has some pretty bad properties. For example, suppose we define a point variable p to contain the null value, as shown here, and it would actually contain the null value if we just declared it as point p, because null is the default value for p. Now suppose we tried to do any kind of point operation with p. For instance, suppose we ask for p.x, the x instance variable of p. Well, the null value is not a point, and so that gives us an error. In particular, it gives us something called the null pointer exception. And if we try to apply any point method to p, we will also get the null pointer exception. So any object operation you try to perform on null will fail with the null pointer exception, and this will lead to these distressingly common bugs that you're going to get from now on in the course. The reason I mention null pointer exceptions now is there's a particularly common mistake that people make when defining a constructor method that can lead to these null pointer exceptions. And here's the mistake. Suppose that when you're initializing the location slot of a Buggle, rather than writing this.pos gets new location or pos gets new location, you write location pos gets new location. It turns out that means something very different. In particular, in execution land, when you say location pos, you are declaring that you want a local variable named pos in your constructor method execution frame, so that when you assign to that local variable, you are not assigning to the instance variable pos, which maintains its value of null. So if you accidentally write the type of an instance variable in the constructor method, you will leave your instance variable to be null, and that will lead to these null pointer exceptions later on. So this is something to avoid. The second point I want to make to wrap up this discussion of constructor methods is that we can actually define constructor methods that take parameters. Suppose we want an alternative version of the Buggle constructor that takes x and y values for the initial location. We can declare the parameters as shown here, and then when defining the method body, we can make sure that the x and y values are in the right range, and then we can use an assignment in which we use those x and y values to determine the location. For instance, if we actually go off and now call our new Buggle constructor with particular x and y values 2, 5, then in the execution frame, we will have the x parameter containing 2, the y parameter containing 5, and then when we get to the assignment, it will create a location 2, 5 and store that in b1's pos variable as opposed to storing 1, 1. So we can declare constructor methods that have parameters. This concludes our discussion of the instance variables and constructor methods for the Buggle class. In the next screencast, we'll talk about the instance methods for the Buggle class.